Hi, math learners. We are on 2.4, 2.5, solving one-step equations, which is what we've done in the last couple of days. But now we're going to add it with integers. So we need to identify what type of math is going on. And by that I mean sometimes there's negatives, sometimes there's a subtraction and a negative, sometimes there's addition and a negative. It's hard to see exactly what's going on. We need to identify the inverse. Identify the inverse. Then, as we said before, we need to show how to solve one-step equations. And then simplify by using integer rules. Let's go ahead and review. I want you to try all three of these in your notebook. Remember, you might need to simplify and then solve. Pause the video to give yourself some time. All right, so m divided by 4 equals 6. We need to solve by getting rid of that divided by 4. And how we do that is we do the opposite or the inverse. We times by 4 on both sides. Remember, you have to do this to both sides. Over here, my 4's cancel out, and I'm left with m equals 24. Okay, this one's a little different. Here, we need to combine like terms. 2b plus 5b really can be combined to say 7b equals 21. Then we need to get rid of that times by 7. The inverse of timesing by 7 is really dividing by 7 on both sides. So we end up with an answer of b equaling 3. So again, for this one, we needed to combine like terms and then do our inverse. Same thing with number 3. That's a pretty long one. First, we combine like terms, and we do that by applying the distributive property. That's what we learned last week, combining like terms. So 5 times x is really 5x. 5 times 4 is really minus 20. Then the rest can be rewritten. Plus 20 equals 15. We still can combine here. I have a minus or a negative 20, minus 20, and a plus 20. That's really 0. Those kind of cancel each other out. So I'm really left with the equation 5x equals 15. I need to get x all alone. So right now, x is timesing by 5. So to get rid of that, I do the opposite, and I divide by 5 on both sides. My 5's cancel each other out, and I'm left with x equaling 3. So at this point, those types of questions, all three of those, you should be able to solve on your own. We are going to move on to what we're working on today. Oh, there's those answers, right? I highlighted my inverses on both sides. Okay, but if you need to pause to look those over and fix your work, do that now. So to solve equations with integers, it's the exact same steps as what we did with positives. Write the equation, simplify if you can, choose the inverse, show the inverse, and solve. You can always check your answer at the end. So here's our first example. We have x minus negative 45. Well, the type of math going on here is a subtraction. So the opposite of minusing 45 would be minusing negative 45 would be to add negative 45. But as we've said, if you do it to one side, you have to do it to the other. So over here, I'm also going to add negative 45. On this side, a minus negative 45 and a plus negative 45 cancel out. I'm just left with the variable of x. Over here, 72 plus a negative 45. You have calculators, so you use them. You might as well type them in and use the calculator if you have it. So we've got 72 plus negative 45 is going to give us 27 because different signs subtract. We subtracted those digits. X equals 27. And we can check that final answer by substituting back in to my original equation. So instead of x minus negative 45, we can say 27 minus negative 45. Does that equal 72? Well, I can plug it back, or I can type it back in. It does. I did my answer correct, or I did my question correct. So my answer, x equals 27, is correct. All right, let's go ahead and look, or you tried this one. So remember, we're trying to get x all alone by showing inverses on both sides. Pause the video while you try it. All right, so I see that the type of math I'm dealing with here is subtraction. So to get rid of subtracting 15, I do the opposite, and I add 15. If I do it to one side, I'm going to do it to the other as well. So again, adding 15 to both sides. Over here, a minus 15 and an add 15 cancel out. I'm just left with x over here. Then negative 16 plus 15 is going to give me a negative 1. I can check my work by saying negative 1 minus 15. Does that equal negative 16? It does. I solved this correctly. Here's my final answer. How did you do? Did you show the correct inverse on both sides? Did you solve negative 16 plus 15 correctly? And did you check your answer at the end? All right, here's another example. X plus negative 3 equals 7. Well, I got to figure out what type of math is going on. I see an addition. I see this subtraction looking sign. It is addition. I'm adding a negative 3. Well, to get rid of adding a negative 3, I subtract a negative 3. If I subtract a negative 3 to one side, I really have to subtract a negative 3 from the other side. As you can see, I showed my inverse on both sides. Well, I'm going to do this one off to the right. 7 minus negative 3. KFC is really 7 plus 3, which is a 10. So I know that 7 minus negative 3 is a 10. These guys cancel out. I'm just left with my x. X equals 10. Now, right away, you might have seen subtracting a negative is the same as adding, and you might have jumped right to the adding of the 3. That's okay to do. Go ahead and you try this one. Pause the video while you work. All right, so first I see that I'm adding a number here. That's the type of math. So to get rid of adding, I know I'm going to subtract. Well, I'm adding a negative 8. So to get rid of an adding negative 8, I subtract negative 8. If I do it to one side, I got to do it to the other side of the equals. Subtract negative 8. My negative 8's over here cancel out, and I'm just left with my y. Over here, 6 minus negative 8, if I KFC that, that's the same thing as 6 plus 8. 6 plus 8 is going to give me a 14. So y equals 14. How did you do? Did you show your inverse on both sides? Did you show the correct inverse on both sides, I should ask? And then, did you solve 6 minus negative 8 correctly? All right, so we've got some table practice here. Go ahead and pick one of these and try it on your own. Pause the video while you work. You could try all 6 if you really wanted to. All right, let's see how you did with those. So here are the correct answers for that table practice. If you need to pause the video for more time to be able to check your answer, correct it if you made a mistake, do that now. So those were all addition, subtraction examples. Now we're going to look at multiply, divide examples. So here I'm timesing by a negative 8. How do I get rid of timesing by a negative 8? Well, I do the inverse or the opposite. Instead of timesing a negative 8, I divide by a negative 8. And if I do it on one side, I have to do it on the other. So these 8's over here cancel each other out. I'm just left with the variable m. And then 64 divided by negative 8 is going to give me a negative 8. I can check my answer and say, negative 8 times negative 8, does that equal 64? It does, which means my answer is correct. M equals negative 8. Okay. Go ahead and you try this one. Pause the video to give yourself more time. All right, so b times negative 10. I need to get rid of the times negative 10 to get b all alone. So the opposite of timesing negative 10 is dividing by negative 10. If I do it to one side, I have to do it to the other. In my previous example, I wrote the division symbol. In this example, I drew the fraction bar. Remember, the fraction bar also just means division. These 10's cancel each other out. I'm just left with a b over here. B equals positive 9. Again, I can double check my work by saying positive 9 times negative 10. Does that equal negative 90? It does, which means I did it correctly. My answer is correct. How did you do? Did you show the correct inverse on both sides? Did you solve correctly? And did you check your answer at the end? Now we're going to look at a type of math that has division. I can see there's a division in there. Well, the opposite of dividing by negative 8 is simply timesing by negative 8. If you do it to one side, you have to do it to the other. So over here, I'm also going to times by negative 8. These negative 8's cancel out, and I'm left with y equals 7 times negative 8, which is going to give me a negative 56. Again, checking your answer at the end, negative 56 divided by negative 8. Does that equal 7? It does. I did my problem correctly. So guys, these are the same as one-step equations with positives. Now the numbers are just a little trickier. Go ahead and you try this one. All right, let's see how you did. We're dividing by -9 because fractions mean division. To get rid of dividing by -9, I'm going to do the opposite and I'm going to times by -9. These 9's cancel each other out. So on the left, I'm left with S equals -5 times -9 is going to give me positive 45. How'd you do? Did you show your inverse on both sides? And did you do -5 times -9 correctly? Reminder, if you don't show your inverse on both sides, you will not get credit. I will send the worksheet back to you. You have to show the inverse, even though right now you might be able to do it in your head. As the problems get harder and harder and harder, you need to know how to show inverses. Again, whatever table you want to try, go ahead and try that. Try multiple tables if you'd like. And then when you're ready, press play and I'll show you the answers. All right, here's my answers. We've got showing our inverse on both sides. That's what I highlighted in yellow. And then my final answer, I put there in red. All right, so self-check. I want you to self-evaluate. Solve these two equations in your notebook, and we'll go over them together as a class.